All right, welcome back, Algebra Express. We are in Rockswold 6.5 properties and applications of matrices. So we're going to talk a little bit about the structure and entries of a matrix, and then we're going to do a little bit of operations. We're going to do some addition, subtraction, and some scalar multiplication. So the first thing they talk about is consider an m by n. Remember, we're going rows by columns matrix. And so this is a sort of numbering system they have. We start with 1, 1. We go 1, 2, 1, 3, 1, 4. And so it's row by column. We are on the first row, and the second number gives you the column. And so you might notice there are n columns going this way. There are m rows going this way. And so the first number is the row. So as you might notice, this is 1, 1, 2, 1. So go 3, 1, 4, 1, up to m1 is what this is saying. And so this is a sub m n. And it says over here it's got the lettering sort of system, the numbering system, sorry. So a sub ij is the entry in the row I, column j. Okay, so let's look at this. So we want to look at this matrix is capital letter B. So you might notice for the matrix we use capital letters. For the entries we use lowercase letters. So for matrix A we're using capital A. For the entry it's a lowercase a. Capital B, the entry is a lowercase b, right? So B21 is row 2, column 1. So we want to go to row 2, column 1. Right there is 5. So if we want B sub 21, that's going to be the entry 5. What does it mean for two matrices to be equal? Well, they have to have the same dimension and they have to have the same entry. So if we're looking at this thing, you might notice, well, 1 equals 1 is something we could get from this thing. That's not really helpful in solving x and y. If we want to solve x, we might notice x is a -7. We might notice like -3 is y, or y is a -3. So we have our x and our y's that we can solve from these things. So the correlating entries have to be exactly the same. The dimensions have to be exactly the same. Scalar multiplication. So scalar multiplication, if I asked you to multiply these things, it's probably exactly like you would probably do naturally. But just to go over it, we want to take this -5 and we want to multiply it to every entry that's in here. So -5 times 7 will give me -35. -5 times -2 will give me a +10. -5 and 3 is a -15. -5 and -1 is a +5. -5 and 0 is going to give me 0. -5 minus 6 is a +30. And I close off my matrices. My matrix. I keep on saying the wrong word. Keep pluralizing it weird, huh? Okay. I'll quit doing it. Matrices must have the same dimensions to add or subtract them. So if we're going to add or subtract the, what does it say? Add or subtract the entries in the same location. Okay, so that's a good way to describe it. 307. So if I'm doing this, you might notice I have some addition here, but I also have some scalar multiplication. So this goes back to the PEMDAS. We want to do our order of operations. So before we do addition, we want to do the multiplication. So do your scalar multiplication first. So 4 times a -2 is a -8. 4 times 5 is 20. 4 times -1 is a -4. And now we just add correlating entries. So 3 and a -8 is a -5. 0 and 20 is 20. 7 and -4 is 3. Okay. So they're going to give us a sort of matrix application problem. And so what they're doing is they're creating a sort of pigment scale here. A low-resolution image of the letter M can be represented by a matrix using a color scale from 0 to 3. So they're using a color scale. 0 is white, 3 is black. We've got 2 shades of gray in there. So they got a grayscale. So the image will be darkened if each entry is increased by 1. So you can do this by adding 1 to each entry. So this image can be represented by this matrix. So if you notice, most of these things are 0. That represents the white space. You see the 2s, that represents that color with the M. So you notice the M with the 2s in there probably. Here's the M. If we add 1 to each entry, it's going to get 1 shade darker. So the M at 2 is going to become 3. It becomes black. The white, it's going to become number 1, which is that shade over here. Okay. To create an image negative. So if you've ever seen Jesus, there's those there's those images you can stare at, right? And what they are like the negative of an image, and then they tell you to stare at a white wall, right? And then your eyes will like see that image. It has something to do with the way your cones adjust on your eyes. And so once you stare at an image, it like inputs that image into your eye cone. And then when you stare at a white wall, you see the inverse of that image. So you can totally do that in some like Photoshop or something really easy. It's like one button. Just says the inverse color. I remember doing it in Paint as a kid. You just stare at it and then you look at a wall. And so there are a few with Jesus. It was where that horrible joke came in. So to create an image negative, subtract the image matrix from a matrix of the same dimensions in which each entry is 3. Okay, so what they're doing is they're taking the darkest most and they're subtracting the colors from it, and you get the image negative. So this is what, 3, 5. It's 5 by 5 matrix. We're subtracting each entry. So everywhere that there's a 2 should now be a 1. Everywhere there's a 1 should now be a 2. 1, 2, 3, 4, 5. So I'm going 1, 2, 3, 4, 5. These are 2s. These are 1s. These are 2s. I'm making that T in here with 1s and 2s. But now the 1s became 2s and the 2s became the 1s. Just subtracting correlating entries. Okay. Oh man, look at this. We're almost done here. This is such a short lesson. I don't even know what I'm going to do for you. Okay, is the operation possible? If so, find it. So number 1, 5a, can we do this thing? 204 minus this matrix. So let's look at this. This is what? 2 by 3. This is I did that wrong. 3 by 2. I told you I'd do that wrong. So rows by columns. So 3 by 2. This is a 3 by 2. We got to subtract correlating entries. So I'm doing 2 minus 5 is what? Minus 3. 0 minus a minus 2 should give me positive 2. 4 minus 3 should give me 1. I'm doing 3 minus 7 should give me a minus 4. I'm doing minus 2. Minus a minus 6 is like minus 2 plus 6 or 6 minus 2. Should give me 4. 1 minus a minus 1 is like 1 plus 1. Should give me 2. So make sure you extend your matrix all the way. Here we go. Part B. Can we do this thing? That's a 1 by 3 and a 3 by 1. I don't think we're going to be able to do that. So, same dimensions. This last one, can we do it? We can absolutely do it. So I'm going to do 503. So if you want to distribute the 2, you have to keep the negative, but I'm going to distribute the negative. I'm going to just make it a plus sign. So if we distribute the negative, -2 and 1 is a -2, -2 and -1 is a +2, -2 and 7 is a -14. Oh man, okay. So close, so close. So 5 plus a -2, here we go, is 3. 0 plus 2 is 2. And 3 plus or minus 14 is like overall going to be negative, and it's going to be 11. All right. Well, I do reckon that is the end of these notes, and I will see you in class soon. Have fun, take care, and goodbye.